Welcome back to our second session on Laplace transforms. So last time we had defined what Laplace transform was. So I'll start from where I stopped. So this was our definition of Laplace transform of a real function. Ft is defined as Laplace of ft is defined as integral of e power minus st ft dt t integration limits from t0 to infinity. This is what we did, and this is a function. This is a transformation. L is a transformation which takes functions in t to functions in S. Please observe this. I want to emphasize this because this causes a lot of confusion. Probably this is the first time you are seeing such a thing. That's why it causes a bit of a headache. So I want you to be clear on this. See, input is function of time, whereas output is function of S. How did it come about? You see, I'm integrating e power minus st ft. So e power minus st ft is an expression in S and t, and then I integrate with respect to t. So still I am retaining t. That means S and t both are there. But integration limits are between t equal to 0 and infinity, which means I'll substitute for t infinity first and then 0 and subtract one from the other. So I'll be left with finally only a function of S. This is what I want to emphasize. So L is a transformation which takes in function of t and returns a function of S. Notation is this: L of small ft is capital F of S. This is the standard notation. We use this all through this course. So note, we said it's similar to what you did with differentiation and integration, very similar notations. Why? Because it satisfies very similar properties, which is the important one for us is linearity. So which means all this we did last time. I'm just recalling. L of ft plus gt is L of ft plus L of gt. Also L of aft is a times L of ft, where a is some constant. It may be real, complex, anything, but it will be constant independent of t. So Laplace transform is what is known as a linear transformation, which means L of aft plus bgt is a lft plus b lgt, where a and b are any constants. We also, what we did is we found Laplace transform for some very elementary functions. So here is the list of all the functions for which we found, at least I mentioned. So Laplace transform of constant function 1. Please note, constant function 1, but t in the definition of Laplace transform, t is varying from 0 to infinity, which means I'm interested only in the first quadrant. Means what happens when t positive, t non-negative. What happens t negative, I am not interested. So this will play a role later. So if I take constant function 1, that means it is 1 everywhere when t is non-negative. Then Laplace transform of such a function is 1 by s. This we have seen. And similarly, Laplace of e power at is 1 by s minus a. Laplace of sin at is a by s square plus a square cos at. And similarly, two hyperbolic functions also we saw. Sin hyperbolic is a by s square minus a square. Cos hyperbolic is this. And we also polynomial. For at least for monomial we saw t power n, where n is an integer. The Laplace transform is n factorial divided by s to the power of n plus 1. There's an extension of this, which proof I did not do it in the class. Anyway, VTU syllabus doesn't demand that you know this proof, but you should know the result. What is the result? T power p. P here, the difference between these two is here n is an integer. Here p can be any number, but greater than minus 1. So p can be, for example, half, root 2, minus 0.3, all these things it can be. In that case, Laplace transform of t power p is gamma p plus 1 by s to the power of p plus 1. These two will coincide when p becomes an integer, because gamma p plus 1 is nothing but p factorial if p is an integer. So both are same. This is more general than this, but this is told in terms of gamma function. Keep this in mind. Normally examiners don't ask questions based on this, but it's there in your syllabus, so you should know. Check table of Laplace transform from the internet. You will see Laplace transform for many more functions. But for your exam, if you know Laplace transform for these functions, it is sufficient. Most others can be derived from this. Anyway, Laplace transform of any function can be derived from first principles. Okay. Our aim is not to keep on finding Laplace transform of various elementary functions. What we want to do is we want to find Laplace transform of complicated functions using linearity. That is the essential thing here. So let us see a few examples. So I want to find Laplace transform of 1 plus 3t square minus 5 to e power t plus 2 e power minus 10t. So how do I find Laplace of such a thing? You go back to your what you have learned in your class 11, 12. You will see instead of Laplace transform, if I had asked you find derivative of this, how would you do it? You would do it term wise. First you would differentiate this, then you would differentiate this, then you would differentiate this, then you would differentiate this, and then add them all together. Add and subtract if there is a minus. Another question. If I asked you to integrate this, how would you do it? Same thing. You would integrate this one first, and then this, and then this, and then this. Correct? Laplace transform also same thing. That is why we use the same notation. What is it that we are exploiting here? Linearity. So Laplace transform of this whole thing is Laplace transform of this plus Laplace transform of this plus minus Laplace transform of this plus Laplace transform of this. Now each one, can I find the Laplace transform? Yes, I know. Laplace of 1, I know. Laplace of 3t square, I don't know, but I can pull out 3. So it will be 3 times L of t square. L of t square, do I know? Yes, I know from the table. So use this kind of argument to find Laplace of this full function, and here are the details. So essentially I use linearity and Laplace transform of standard functions from the table. So this is the procedure. L of this whole thing is L of each one of these with appropriate signs in between, which is same as I pull out constants as much as possible. So L of 1 plus L of 3 LT square minus 5 L of e power 2t plus twice L of e power minus 10t. Laplace of each of these functions I know. Laplace of 1 is what? I know it from the Laplace table. It is 1 by s. So I'll write that 1 by s. And similarly, Laplace of t square is 2 factorial by s cube. Laplace of e power 2t is 1 by s minus 2. Laplace of e power minus 20 is 1 by s minus a. Minus a is minus 10, so minus a is plus 10. So Laplace of e power minus 10t is 1 by s plus 10. So Laplace of this function which I was looking for is precisely this. You don't have to try to evaluate this, or not evaluation. You don't have to, what is this called? Simplify. You don't have to simplify this term. Just leave it like this. It looks pretty bad. You don't want to simplify a term like 1 by s plus 3 into 2 factorial by s cubed minus 5 by s minus 2, etc., etc. Just leave it like this. So this is how, so the bottom line is you have to use the linearity of Laplace transform. That's why I emphasize so much on linearity of Laplace transform in my last class. So let us try to find more examples. Let us try to find more examples which uses linearity. So here is another example. Find Laplace transform of 5 power t minus 3 cos 2t plus 4 sin x 3t. Same trick. If I ask you to integrate this or differentiate this, how would you do it? Same way you proceed. So use linearity and functions, Laplace transform of standard functions from the table. So this is nothing but what you see on your screen. L of 5 power t minus 3 cos 2t plus 4 sin 3st is this. L of 5 power t minus, like how would you different, instead of L, if it were d, this is what you would have done. D of this whole thing is d of this minus d of this plus d of this. Here at the one step itself I have pulled the constant out. Same thing I do. Now how do I find Laplace of 5 power t? T power 5 I know. How do I find 5 power t? Same, how would you integrate or differentiate here? You would put 5 power t equal to y and then take logarithm and do it. No, same thing you do. I won't write all the details. It's written here. 5 power t is same as e power t log 5. Go home and check veracity of this. You must have seen it already several times before. So this look 5 power t is same as e power t log 5. So log 5 is clearly a constant. So this looks like e power t a or e power a t, where a is log 5. So then I know Laplace of this, I know Laplace of this, I know Laplace of this. So I write, that's it. So remember, even if the independent variable is in the power, I use basically this transformation or this, you can interchangeability. You can write this as this. Both are same. And for this, I know Laplace transform, so I know Laplace of this. So game is about reducing the given function to one of the elementary functions whose Laplace transform is known. Elementary functions means those 8 functions in the table. So if you can reduce it to them, you are done. So here is a list of tricks how to reduce it to those functions. I'll illustrate these by showing you various examples. So let's start with this powers of hyperbolic functions. So that means I have something like this cos h square 80 or sin h cube 80. Then what do I do? You use the definite. You must always ask the question. When somebody asks you to find Laplace transform, you must always ask the question. How would you if somebody asks instead of Laplace transform, if somebody asks me to differentiate this, how would I do it? Or if somebody asks me how to integrate it, how would I do it? That's your question. I mean, that is the answer to finding Laplace transform. If you don't know how to differentiate this, there is no way you can find how to find Laplace transform. How do you differentiate this? Think for a minute. Cos hyperbolic square 80. How do you do it? Most probably you understood. You will write the definition of hyperbolic cos. That is e power 80 plus e power minus 80 by 2 and differentiate it termwise. Do the same thing here. Write the definition of hyperbolic cos or hyperbolic sine, expand it out, and if it's a power, you'll have to expand it, and then do the differentiation or integration or Laplace transform term-wise. Maybe it's too abstract, I'll show you in a specific example. So find Laplace transform of 3 hyperbolic cos square phi t. So how would I do it? So write down the definition of cos hyperbolic phi t, which is e power phi t plus e power minus phi t by 2. So its square will turn out to be e power 10t plus 2 plus e power minus 10t by 4. A plus b whole square, a square plus 2ab plus b square, and denominator square I written as it is. So I can rewrite this as 3 terms, e power 10t by 4 plus e power minus 10t by 4 plus half. Why have I written like this? Because it's easy for me to find Laplace of each of them. So Laplace of cos hyperbolic square phi t is nothing but 1 by 4. Means I'm using linearity here. Laplace of this is same as Laplace of this. Laplace of this means I can pull out constants and write Laplace of whatever is left inside. That's what I have done here. So each of these I know. Laplace of e power 10t is 1 by s minus 10. So 1 by 4 outside remains like that. This is 1 by 4 1 by s plus 10 because a is minus 10 here. And the last one is I pull out half, I get L of 1. L of 1 is 1 by s, and outside I have pulled out half, so 1 by 2s. So this is the final answer. This is how you do for powers of hyperbolic functions. Basically, use the definite. I mean, this is how you would integrate or differentiate. Also. If somebody asks you to integrate, oh, I have made a small mistake here. It's not a mistake. It's not a big deal. I have asked to find here Laplace of 3 cos h square phi t. But finally, I ended up writing Laplace of cos h square phi t. So multiply the whole thing by 3. I'm sure you understand what I'm saying. It will be Laplace of 3 times cos h square. So 3 I'll pull it out. So all through I'll have 3 here. That's the final answer. Everything I written is correct, but I have not answered the question which was asked. I have answered the question instead cos h square phi t instead of 3 cos h square phi t. That's okay. It is multiplied by 3. I hope I didn't confuse you more. So the idea I'm trying to tell you is whenever you have hyperbolic functions, powers of hyperbolic functions, use the definition of hyperbolic function and expand it out and find its Laplace transform. Now let us try another one. I have squares of sine or cosine. How do I do this? Well, I don't have both of them, one of them. I'm not doing something like sine square 80 plus cos square bt. That also you can do. But right now I'm taking one term at a time. So let us take some one from. How do you do this? No, I told you. How do you, when somebody asks you find the Laplace transform of this, take cos square 80. What should you be doing? First thing you must do is you must ask the question. How would I differentiate cos square 80? Or even better, how would I integrate cos square 80? Differentiation is easy because you do some chain rule and Leibniz rule and things like that and get away with it. But integration, how would I integrate cos square 80? You recall from your class 12, how do you integrate cos square 80? Yes, you use this formula. Cos 2t is 2 cos square t minus 1 and rewrite cos square t in terms of cos 2t and then you will integrate. And it's all integration is linear operator, so you can pull out half and do whatever, all the usual things. So maybe if it's a bit abstract, let's see one specific example. Find the example is this. Find Laplace transform of sine square 70. So I'll use this formula. Cos 2x is 1 minus 2 sine square x. This we know. How do you remember this? I'm sure you know it. If you have forgotten, cos 2x is cos square minus sine square. Remember, cos square x plus sine square x is 1. Cos square x minus sine square x is cos 2x. That's what we have used. And cos square I know is 1 minus sine square. So if you put that, you get 1 minus 2 sine square. So cos 2x is 1 minus 2 sine square x. Uh, if you use that, put x equal to 70 here, then you will get sine square 70 is 1 minus cos 270, that is cos 14t divided by 2. This 2 will go down. So how do I find Laplace of this? And that means Laplace of sine square 70 is same as Laplace of 1 minus cos 14t by 2. Now Laplace of this I will use linearity. This I'll write it as half minus cos 14t by 2 and use linearity. So Laplace of this is Laplace of this minus Laplace of this. Laplace of this means pull out the constant again. So half I'll take it out. So it will be L of 1. In this if I take half out, I get L of cos of 14t. Both I know how to find. L of 1 is 1 by s. Cos 14t Laplace of cos 14t is 14 by s square plus 14 square. So this is the final answer. So this is how you find Laplace of sine square. Instead of sine square, if you had cos square, also similar formula. Cos 2x is 2 cos square x minus 1. That's what I would have used. Basically, the idea is I know integration of cos 2x. I use that to I exploit that to find integral of cos square or sine square. Basically, this formula is the underlying thing which helps you to solve this problem. Now this was product of sine square means sine into sine. Like sine square 70 means sine 70 into sine 70. Now I want to extend this. Instead of sine 70 into sine 70, what if I had sine 70 into sine 80? How would I do it? I can't use this formula. But anyway, trigonometry is full of formula. You will have one more rich brother formula. Here it is. This I have written all these three in one slide because this is very, very important for you from examination point of view. Not just for Laplace transform, we will use these formula in and out in this course for first three modules. The formula are sine 80 into sine bt. Probably you will have heard it in terms of sine c, sine d and things. I don't know how. Sine a into sine b is half cos a minus b minus cos a plus b. That's what you might have heard. But because in this course it's more relevant to call this as AT, I'm calling it AT, BT, etc. etc. So these formula are very important. I cannot overemphasize this how many ever times I tell. So sine 80, sine bt, I'll just read once. I hope I have written correctly, but just check once. Sine 80 into sine bt is half cos of a minus bt minus cos of a plus bt. Sine of 80 into cos bt is half sine of a plus b times t minus sine of difference. Cos of a cos b is half cos sum plus half cos difference. So this you must have heard about some one difference formula in your class 11 and 12 or whatever. So these three are important. What is important about it? If I am asked to find Laplace of this, I have to find Laplace of this. Laplace of this is easy to find because Laplace of this minus Laplace of this. Laplace of this I can find. Cos something times t I know. Correct? So that is what we use. Maybe in an example, here it is. Laplace of sine 70 into sine 5t I want to find. How do I do it? I use this formula. What's the formula? Sine 80 into sine bt is cos of a minus bt minus cos of a plus bt by 2. So sine Laplace of sine 70 into sine 5t is nothing but Laplace of half I will say finally, cos of a minus b, 7 minus 5t is 2t. minus cos of a plus bt, that is 7 plus 5, 12t, divided by 2. So Laplace of this is, I can pull out half out. I can pull half out. In fact, I'm going to write down this in two terms. I'll pull out half and write Laplace of cos 2t minus cos 12t as Laplace of cos 2t minus Laplace of cos 12t. Both I know how to find. The half I'll keep it as it is. Laplace of cos 2t is 2 by s square plus 2 square minus 1 by 2, 12 by s square plus 12 square. So this is the final answer. For what? Laplace of sin 70 sin 40. Similarly, if you add sin 70 cos 40, then the formula would have been slightly different. What is the difference? There it is. Here, if it were sin cos, I have written the formula here. Sin cos would be sin sum minus sin difference. So it would have been slightly different in the sense these two terms, these two terms would have been different, but they would be in terms of sine or cos, for which I know Laplace transform. That's the standard trick one uses to find product of sine or cos, product of trigonometric function. Trigonometric function means everybody we want to find only sine and cos. Why, I won't tell you. You please go home and see the definition of Laplace transform. For example, why would I not talk about Laplace transform of tan x? See the definition of Laplace transform. It is e power minus st into ft. But here ft, if it is tan t and t running from 0 to infinity, tan t is not even defined everywhere. For example, pi by 2, minus pi by 2. These are the places where tan is not even defined. So you can't talk of tan of Laplace transform. Don't bother. I'm not going to talk about those kind of things. In our course, we are interested for sine and cos only. So this is the trick which we used. If I have product of sine and cosine, we use these formula. At times we may have to use this formula repeatedly. For example, if I have, instead of sin 80 sin bt, I could have sin 80 sin bt sin ct. Three terms: sin 80 sin bt sin ct. Do you have a separate formula for that? We haven't written down, but one can make one. Sin 80, keep it like that. Sin bt into sin ct, use this formula. Expand it. Then you have sin 80 into this, sin 80 into this. Then I'll have sin cos, sin cos. For that there is a formula here. Write it down. You can understand. So no, write down that formula, but I illustrate this using the example. So here is the example. I've chosen an easy one, and if you check the way I have solved here in the PPT, and the way I have solved in the notes which are available for you on the website are different. Note answer is the same. Both are slightly different. Method is same, but slightly different way of solving. I'll expound on it. I'll sort of point out what's the difference. So let us start with this. Sin t, sin 2t, sin 3t. Product of this. Its Laplace transform is what I want to find. So let us use the formula. Formula says what? If you have two sines, keep them. In the sense, use the formula. So I'll keep sin t as it is and use formula for sin 2t, sin 3t. Sin 2t, sin 3t is half cos of 2t minus 3t, which is minus t, minus cos of 2t plus 3t, which is 5t. So sin t, sin 2t, sin 3t is nothing but sin t into half of cos of minus t minus cos 5t. Cos of minus t is cos t only. No, cos of minus x is same as cos of x. You might have known it as cos of minus theta is same as cos theta. So you expand this. Half sin t into cos t minus half sin t into cos phi t. Half I have kept it outside only. So sin t into cos t minus sin t into cos phi t. Now, if I want to find Laplace of this, I have to find Laplace of this. In this, I'll take half out and I'll be left with Laplace of this whole thing. How do I do that? I use formula sin t cos t. Sin t cos t, what is the formula? Sin of t plus t minus sin of t minus t with a half. So that half I have taken out, it's become 1 by 4. Similarly, for this sin t cos phi t, minus is there here. So minus sin of t plus phi t and minus, but there's a minus here, so minus into minus plus sin of t minus 4 phi t, which is minus 4t. It is easy to evaluate. Sin 0t is 0, so that doesn't come at all. So, and this also comes with the half which I have pulled out, so I have written 1 by 4 directly. So 1 by 4 sine 2t minus sine 60 plus sine 4t. Remember, sine of the mistake here, sine of minus t is minus sine t, right? So I have written plus here. This is not plus, this should be minus there. But let us check the formula for sine cos comes with a minus. Right? Sine cos comes with a minus. So this will be a minus. This is the mistake. This is not plus. No, there is plus only because there is a minus here. Minus into minus will become plus. Finally, this should have been minus. I don't know why there is a small error here. This you can check. You understand what I'm trying to say. Here, if the sine of minus theta is minus sine theta, that's correct. So sine of minus 40 is minus sine 40. So this should have been a minus here. So just check that if I have made a mistake there. So I'll get this L of sine t, sine 2t, sine 3t is L of this whole thing, probably with a minus here. So I'll get this. Now I use linearity and then I get this. Check whether this is minus. One can check with my notes also. We'll get this. It should get the same answer. I don't seem to check that. Please do that. So that's the answer. Just with the modular fact that whether this is plus or minus. That's okay. No problem. So basically I've shown you an example where you have to use this formula repeatedly. Maybe twice we have used. Somebody doesn't like you, they could give you 4 products. Sine AT, sine BT, cos CT, cos DT. Then you have to use the same formula 3 times and write it. So it's painful, but it can be done in a very similar way. So this is another trick which you need to know. In fact, remember, I forgot to tell, remember, this is how you would integrate also. How would you integrate sine AT, sine BT? The same thing you would do. Because I know integral of cos A, something t. So I can do that. So how would you integrate? Same way you find the Laplace transform also. Okay, next kind of example is if it has cubes of sine or cosine. So how would you do this? Again, how would you, differentiation is easy. How do you integrate this? How do you integrate sine cube 5t? Basically, you would use 3 sine, this identity. Sine 3t is some formula, right? So that's the formula I have used here. Sine 3t would be 3 sine t minus 4 sine cube t. So I have used that ulta. For sine cube 80 is 1 by 4 sine 3 sine 80 minus 3 sine 80, minus sine 380. Similarly for cos cube also. So if I want to find Laplace of this, I want to find Laplace of this. Laplace of this is easy to find because I have to pull out the constants and here I am left with only sine 80 or sine 380 and sine 380. Sine 80 I know Laplace, sine 380 I know Laplace. So together I can find the Laplace. Maybe there's an example. No, there's no. I have not written an example here, but it follows very similarly. Later on somewhere I'll show an appropriate example. No problem. So I hope this is clear how to find Laplace transform of cube of sine and cosine or cosine. Either case you use. So basically you see your trigonometry formula is what you must be strong in. You must know those formula well. Then you will be able to solve these Laplace transform. Trigonometry formula means basically you should know how to integrate. If you know integrate sine cube, then you know how to find Laplace transform. If you know how to integrate sine A cos B, then you know how to sine not sine A cos B, sine AT into cos BT because the t is a variable. So you integrate the variable. So sine AT into cos BT, you know how to integrate. Same way you find Laplace also. So there's nothing new in this. It's just formula, same formula, trigonometry formula you use, but final thing, instead of integral of sine 80, you have Laplace of sine 80. But for that you have some formula. I've shown you in the table of Laplace transforms. So you use that. Sometimes, not very often, but is there in your syllabus. Normally they don't ask in the exam, but still I would like to tell this. You may have to take recourse to power series. Example. So if I ask you to find Laplace transform of sine of t square, try to understand sine of t square, not sine t, into sine t. It's not sine square t. It is sine of t square. How would I do it? Same question you are asked. How would you integrate? If you are asked you to integrate sine of t square, how would you do it? Not easy. I don't know if you have done it. So what you do is use power series expansion. Maybe you are not done it in class 12 because you don't know power series in class 12. But in your first year B, you have been taught this like what I used to guess. Taylor series and Maclaurin series. So there you have to use this Taylor series or Maclaurin, whatever, zero into Maclaurin. So sin x series is x minus x cubed by 3 factorial plus x power 5 by 5 factorial, etc., etc. So if I put instead of x p power n, I will get sine of, so let's take an example, n equal to 2. So that means sine of t square. Sine of t square is t square minus t square whole cube, that is t power 6 by 3 factorial, plus t square whole power 5, t power 10 by 5 factorial, etc., etc. So Laplace of this is Laplace of this. That means Laplace of t square. That I know how to find. Laplace of t power 6. That I know how to find. By 3 factorial also doesn't scare me because I will just pull out the constant. So use same linearity, and every term is some power of t. So some power of t I know how to find Laplace. So I am done. So you can find Laplace of sine of t power n. Similarly, cos of t power n, you have to use a different series formula. They are related. If you go and see, e power I theta is what marries sin x and cos x. You know e power I theta. We have done that also while trying to find Laplace of sine. E power I theta is sin theta, cos theta plus I sin theta. That's where this series also comes. Because I know e power x is 1 plus x plus x square by 2 factorial plus x cube by 3 factorial, etc., etc. Put x equal to I theta there and try doing this. So this series, what I'm trying to tell is you don't have to spend too much energy trying to remember this series. It comes from e power ix, that's all. So in general, cos t power 5 or sin t power 5, I know how to find Laplace of it. That's the upshot of this. Another popular series with examiners is this 1 by 1 minus x is 1 plus x square plus x cube plus etc., etc. I don't know, you may have seen it, sometimes you might have seen it in case of your convergence and things like that, or even in your geometric series, sum of 1 plus r plus, if my geometric sequence is 1 r square, r cube, etc. Sum to infinite terms is 1 by 1 minus r. You notice. So S infinity 1 by r, 1 by 1 minus r. So same thing, instead of r, I am using x here, the geometric sequence, but mod x is less than 1, of course. Otherwise, it diverges, it doesn't make sense. So this is another popular series. For what do you want to use this? If somebody asks you to find Laplace transform of such a horrible looking function, 1 by 1 minus e power t, how to find it? So you write this, 1 by 1 minus x is this. So 1 by 1 minus e power t is replace x by e power t. You will get 1 plus e power t plus e power t whole square, which is e power 2t plus e power t whole cube, which is e power 3t, etc., etc., etc. Laplace of this is same as Laplace of this, which means Laplace of 1 I know, Laplace of e power t I know, Laplace of e power 2t I know, Laplace of e power 3t I know, like that Laplace of e power nt I know, right? Laplace of e power nt is 1 by 1 s minus n. Remember, Laplace of e power ax, e power at is 1 by s minus a. That's what you have to use. So one can use this to find Laplace transform of this kind of function, 1 by 1 minus e power t. You could have many other functions. You can complicate your life a bit more for this power series. Normally, they don't ask too much of these kind of things in the exam, but it is there in your syllabus, so I have mentioned this. There is one more thing which keeps coming in the syllabus again, is how to find Laplace transform of root t plus 1 by root t. Root t means, yeah, that's I know. Root t is same as t power half. T power half, do I know? So, firstly, use linearity, which means Laplace of ft is Laplace of root t plus Laplace of 1 by root t. How do I find Laplace of root t? I have written it here. Laplace of root t means Laplace of t to the power of minus half. T to the power of minus half, how do I find Laplace? I told you in the table of Laplace transform that last entry was Laplace of t power p, and p is greater than minus 1. So p here is half. which is greater than minus 1. So for that, Laplace is gamma p plus 1 divided by s to the power of p plus 1. So gamma half plus 1 divided by s to the power of half plus 1. Similarly, Laplace of 1 by root t, if you take this up, then it will become t power minus half, which is also greater than minus 1. So it is gamma of minus half plus 1 divided by s to the power of minus half plus 1. You evaluate this, you know this. Gamma of 3 by 2 is 1 by 2 gamma half. So unless you know properties of gamma functions, you can't do these things. This you must have learned your gamma functions sometime in your first semester or second semester. So unless you know gamma functions, you can't solve these properties. Okay? You have forgotten definition of gamma property, gamma function. Just go and recall. So gamma half you know is root pi also. All these things were taught to you last semester. Mathematics is like building from the previous one. You can't forget that. If you say I've forgotten everything from the last semester, you can't continue doing mathematics now. You have to build upon it. You have to recall. So go home, quickly check your old notes or old textbook, whatever you want. If nothing is available, I have given enough. I will give enough web resources. Go and check on that. All these things will be readily available. So I told you how to find the Laplace transform of a function like this root t plus 1 by root t. Yeah, I think that finishes our one part of the slide. Uh, I'll continue. So this is the next part. I want to now tell, so just let me recall. What have we done? We have defined what is the Laplace transform. We have found Laplace transform of some very elementary functions. Using the Laplace table of elementary functions, I have found Laplace of some horrible looking functions, but every time it was not very horrible because I have been using linearity. That's how I cooked up the functions. For example, I never told you how to find Laplace of sine of cos t and things like that. So I don't even know how to integrate sine of cos t. So it's very difficult to find Laplace also. We are not interested in that kind of functions. We are interested in more examination kind of, you just uh, using linearity property of Laplace transform, I should be able to find Laplace transform. That is what we have used. In the process, I've shown you how formula of trigonometry plays a very important role, and you will have to know those things. Otherwise, you won't be able to solve. Now, what I will do is I will give you a list of properties of Laplace transform. These are very important, and then proofs are very easy. But proof are not there in the syllabus, so I have not put those proofs in this set of lectures. Anyone interested, send me a mail. I'll definitely let you know. But I'm sure you can find it on the internet or in your textbooks or somewhere it's available. Ask your teachers; they'll be able to tell you. But I recommend these proofs be written by students on your own to understand what Laplace transform is. That's choice is yours. So let me write down the properties. First one, at times this Laplace transform looks scary. I told you before also. The scary part comes from the following thing. Laplace of ft is capital Fs. That means input I'm giving you a function of t, but output is coming function of s. Our s and t related, nobody knows. I mean, not nobody knows, means they are not related actually. So that is the scary part of Laplace transform. Don't worry. As I told before, nobody, I don't know anybody who understood Laplace transform in the very first course. It will take time. You have to be at it. Sometime you will understand that this is not very difficult and there are some very elementary tricks which you have to follow. So properties look more horrendous. That's why I'm giving you all this preface. So check these properties. This is names are also there. Not very important. Most of these names come from engineering. Change of scale property or change of time. L of f of at is 1 by a f of s by a, where what is small f is the function and capital F is the Laplace of small f. So this is the notation which we will have fixed up for throughout this course. L of whenever I write capital F of s, you must know there is a small f whose Laplace happens to be capital. This is a standard thing. I won't keep telling this again and again. Initially to recall I'll tell, but later on I won't even talk about it. So Laplace of small ft is capital F of s. So Laplace of f of at is 1 by a capital F of s by a. This means if I know Laplace of ft, I know Laplace of f of at. So it's like change of scaling the time. Time everything is doubled or tripled. Then t becomes 2t or 3t or 5t or we change it by a times, it will become a. So if I know Laplace of ft, I know Laplace of f of at. That's what this formula tells. How do I know? Basically, this is the formula. L of f of at is 1 by a, capital F of s by a. So wherever s is there, I replace it by s by a. This is not a very useful property, let me tell you. But this is there in your syllabus, so I written it down. And yeah, it's a fair enough. You try to prove this, you will understand many things. The next rule is, this is very important. The next few rules which I am telling you, next three of them to be precise, they are all very important for your examination point of view and even from the application point of view. The rule is change of frequency. It's also called shifting. Is the following. Laplace of e power at into ft is f of s minus a. What does this mean? Let's try to understand this. Notation is the same thing. L of small ft is capital F of s. So that means if I know Laplace of small ft, which is capital F of s, if I know this, then I can find Laplace of e power at into small ft. That is nothing but whatever was capital F of s. Instead of s, I'll write s minus a. Where did a come from? Whatever I multiplied e power at with. Rather, whatever I multiplied ft with, which is e power at, this a shows up here. This is a very important rule. So what content of this is, if I know Laplace of ft, I can find Laplace of e power at ft. So multiplication by e power at is not a big deal as far as finding Laplace transform. That's what this formula says. Easy proof. I told you I'm not going to write it down. You please go home and try to write down the proof. It follows from the first principles. It's very easy, just from the definition. Nothing else. So Laplace of e power at ft is capital F of s minus a. So replace f of, what is this f of s minus a? F of s is Laplace of ft. That's, so if I know Laplace of ft, I know Laplace of e power at into ft. Maybe I should show you an example, then this will become clear. Just I'll tell you the other two rules and then go to example. Maybe no problem. I'll go straight to the example. Afterwards, we'll come back to the rules. So let us try to find Laplace of e power 2t into sine 4t. So understand here, I have a function. This I don't know how to find Laplace of this right now. Laplace of e power 2t into sine 4t. I know how to find Laplace of sine 4t. I know how to find Laplace of e power 2t. But Laplace of this product is not product of the Laplaces. It's like integration. Product of two functions integration is not product of integration of two functions. When you take two functions, sin x into cos x, integration of that is not equal to integral of sin x into integral of cos x. Similarly, Laplace of e power 2t I know, Laplace of sin 4t I know, but that doesn't mean I know Laplace of e power 2t into sin 4t. But no, Laplace does not respect your usual product. So what do? For that I use this formula. This what is the formula? For that I'll observe this function, given function is of the form e power at into ft, where ft is sine 4t. I know sine 4t is Laplace, I know. So Laplace of sine 4t is 4 by s square plus 16. How do I know this? I use the table. So use the shifting formula. What does the shifting formula say? Here is the shifting formula. Laplace of e power at ft is capital F of s minus a. This means if you want to find Laplace of e power at into ft, find Laplace of ft. And then in that you replace s by s minus a. That's what I have done here. Laplace of ft I have found, which is 4 by s square plus 16. And in this is fs, right? So L of ft is f of s, which is 4 by s square plus 16. In this f of s, you replace s by s minus a if you want to find Laplace of e power at ft. So then Laplace of e power 2t sine 4t, a is 2 here. So replace s by s minus 2. 4 by s minus 2 whole square plus 16. Hope it's clear. Just go through this once. Laplace of sine 4, I want to find Laplace of e power 2t sine 4t. How do I do that? I observe that this function is of the form e power at into ft, where ft is equal to sine 4t. What's the advantage of this? I know Laplace of sine 4t. That means I know Laplace of small f t, which is 4 by s square plus 16, and this is what I will call capital F of s. That's a notation. Laplace of f small ft is capital F of s. Now, shifting formula says Laplace of e power at ft is capital F of s minus a. I know capital F of s. No, I know capital F of s minus a. I just replace s by s minus a. What is a? A comes from this part. What is it that I'm multiplying ft with e power at? That's the a. In this case, I'm multiplying by e power 2t. So a is 2. So replace s by s minus 2 over. That's all. Go through the slide once carefully. Once more. Okay. So now this is one formula. There are two more formula which I want to illustrate. So let me go back to this. So this is what we have seen just now. Shifting rule or change of frequency. In change of frequency here, you see, I told you frequency is what is the argument of capital F. Here frequency is changed s to s minus a. Right? So it's called change of frequency rule. I won't want to tell you all the physical details of all the physical significance of all these things that you will learn in the next part of your course in your department when you do network analysis or signals and systems and things like that. You will see the application, the meaning of why is it called change of frequency and things like that. Now, right now, I don't have time energy for that. So this is the, but you must remember this rule. Laplace of e power at ft is capital F of s minus a. Short of this is, if you know Laplace of ft, I can find Laplace of e power at ft. That is the bottom line. If I know Laplace of ft, I know Laplace of e power at ft. How do I know? Just to replace in Laplace of ft, you will have a s term, but replace s by s minus a. That's all this says. As simple as that. The next one is very important. Is similar thing. Instead of e power at, what happens if I give a monomial like t power n? So I'm multiplying ft by t power n and trying to find its Laplace. The formula again. I won't tell you the proof where the formula came from. It's easy. Use some induction and use the definition. The formula is this: Laplace of t power n ft is minus 1 power n d n nth derivative of capital F of s. I mean, you differentiate this n times, painful procedure. This is the formula. But don't worry, you don't have to do too much. This formula is most useful when n equal to 1. I mean, from the examination point of view. When n equal to 1, what happens? L of t ft is what I want to find. N equal to 1 means I am multiplying ft by t. The formula is for ft multiplied by t power n equal to 1. So L of t ft is n equal to 1 means this is minus 1 into d by ds of f of s. So that means you are differentiating capital F of s once and change the sign. That is Laplace of t ft. Here it is. Most useful, this formula L of t power n ft is minus 1 power n d by dns of capital F of s. What is capital F of s? Same thing, Laplace of small ft. Remember that. This is a standard notation. This is fixed for this module. Whenever I write capital F of s without saying anything, I mean it is Laplace of small ft. So if I know Laplace of small ft, I know Laplace of t power n ft. You must have done Leibniz rule, right? Or differentiation. Integration is very difficult. If you multiply by a polynomial, like for example, integral of sin x, you know, how do you find integral of t square sin x? Very painful. But you had a rule, some integration by parts, you do it, but you have to do it twice and thrice and things like that. It was very painful. Similarly, you have a formula for Laplace of t power n into ft in terms of Laplace of ft. That is the formula which is given here, and this is most useful when t n equal to 1. So when n equal to 1, it looks like this. L of t ft is minus, many books they'll write it as f dash s. So don't get confused. F dash s is same as d by ds of f of s. I have written it explicitly so that you don't get confused. So L of t ft is minus d by ds of f of s. So if you know f of s, differentiation, if you differentiate once and change the sign, that is the Laplace of t ft. So if I know Laplace of sine t, which I know, very easy to find Laplace of t sine t. All I have to do is to differentiate Laplace of sine t once with respect to s and change this sign. That is what this formula says. This is very useful. I will show you an example using this. In the last but not least, this is another very important formula which says Laplace of ft by t is integral of capital F of s ds. Here, how much time do I have? I have another 10-15 minutes. Okay. So I'll try to, I'll give you some way of trying to remember these things. Remember, I told you in the first class that Laplace I am using basically use of Laplace. The main application of Laplace is to solve differential equations. How, as I told you, it will convert differentiation into an algebraic problem. Algebraic problem means it will convert it into some polynomial. That is what this is doing. You see, differentiation, it's converting into polynomial. Means if you differentiate, I know it's not very clear right now, but think of it as an idea. Differentiation of capital F of s is like multiplication by t. So it's converting into a multiplication problem. You also know differentiation and integration are inverses of each other. Ulta. One is the inverse of the other. So instead of differentiating, if you integrate, instead of multiplying, you would have to divide. That is what this is happening. L of t ft is minus d by ds of f of s. L of ft by t is integration of f of s ds from s to infinity. Remember these limits also, they are important. Laplace of ft by t is integral of capital F of s ds from s to infinity. So these are the four formula. These three are very important. Okay, which are the three shifting rule, which is L of e power at ft is f of capital F of s minus a. L of t power n ft is minus 1 power n d. Nth derivative of capital F of s. This is particularly useful when n is equal to 1. And then Laplace of ft by t is integral of capital F of s, limits between whatever is shown, s to infinity. I'll show you examples illustrating power of this formula, these rules. These properties, as I told, very easy to prove, but proof is not in your syllabus, so I'm not going to write down the proof. But they are pretty easy. These are already shown you. Laplace of e power 2t sine 4t I have shown you, so I won't discuss this. Let us find this. Laplace transform of e power 4t into t power 5. How do I do this? Very easy. You see, given function is of the form e power at into ft. Its Laplace transform is easy for me to find. So it's easy to find Laplace transform of e power at into ft. That's the trick you must observe as soon as you see the problem. So once somebody asks you to find Laplace transform of a function, you must see in this function which is the part for which I can find Laplace transform and how I can exploit the other factors. That is what you have to see. That's what this whole course is about. This part of the course is about. So let us see how to do it. Given function is of the form, say, the e power at ft, where ft is t power 5. And I also know Laplace of t power 5 is 5 factorial by s power 6. So now use shifting formula. What does it say? Laplace of e power at ft is capital F of s minus a. So f of s is this. That's what L of ft is f of s. F of s is 5 factorial by s power 6. So in this, I replace s by s minus a. What is a? 4 here. So I replace it by s minus 4. So Laplace of e power 4t t power 5 is 5 factorial by s minus 4 whole power 6. I hope it's clear. exactly like what you did in the previous case. If you have e power at into some function, and if you know the Laplace of this function, I know the Laplace of e power at into that function by just replacing s by s minus a. As simple as that. That's what we do here. So let us try to be a bit more, exam kind of problems. Let's try to work out. So here it is. Laplace of e power minus 3t into cos square 5t. Uh, Here again, I see this is on the form e power at into ft, where ft is cos square phi t. So if I know how to find Laplace of cos square phi t, I know how to find Laplace of e power minus 3t into cos square phi t. How? By using shifting formula. In Laplace transform of cos square phi t, I'll replace s by s plus 3. A is minus 3 here. Replace s by s minus a, which is s plus 3. That's all. So my life goal is now to find Laplace of cos square phi t. How do I find Laplace of cos square phi t? I already told you the formula. How to find Laplace of square of cosine? There is a formula. I know that. So all this I just told you. So I have to just basically find Laplace of cos square phi t. How do I find that? So all this I have told you. Yeah, here it is. So how do I find Laplace of cos square phi t? Here, use this formula. Cos 2a is 2 cos square a minus 1, and that is cos square phi t is equal to cos 10t plus 1 by 2, because you put a equal to 5t here in this. You put a equal to 5t, cos square phi t is equal to, this 1 will go this side, 1 plus cos 10t, because a is 5t, divided by this 2. So cos square phi t is cos 10t plus 1 by 2. We have already done this kind of problem, but just to emphasize, I am redoing it. But I'll be, of course, faster. So Laplace of cos square phi t is this. So using linearity, I know Laplace of cos 20 and Laplace of 1, which are these. So I know Laplace of cos square phi t. If I know Laplace of cos square phi t, I know Laplace of e power minus 3t cos phi t. All I have to do is in this f of s, which is 10 by s half, 10 by s square plus 100 plus 1 by s, I have to replace s by s plus 3. That's what I have done here. That's it. Don't even have to try to simplify this. Don't try. It's a horrible way to, horrible expression you will get. I mean, use this. So just leave it like this. This is perfectly correct. So Laplace of e power minus 3t cos square phi t is half 10 by s plus 3 whole square plus 100 plus 1 by s plus 3. Don't try to see what it is. Here it is just whatever was here, replace s by s plus 3. That's all you need to do. And now let's try to look for one more example. This is the other formula. Laplace of t cos 6t. So here it is of the form Laplace of t into ft. I know how to find. If I know Laplace of ft, I know how to find Laplace of t ft. How do I do that? With the formula. So I'll recall that formula. So this is of the form. So first thing, before you start, when you see this, you must observe that this is of the form t into some function whose Laplace is easy for me to find. If I know how to find Laplace of this function, then I know how to find Laplace of t times that function. That's the bottom line. So this is of the form t into ft, where, and I use this. What is this? This formula. L of t ft is equal to minus d by ds L of ft. L of ft I can find very easy. Ft is cos 60. So this is just s by s square plus 36. Now I have to differentiate this. This is like first PUC problem. How do I differentiate this? And change the sign. Is that clear? I hope so. So I'm using this formula. Previously I used e power at into cos 60. I know how to use. You change from s, you change to s minus a. Here I'm using t into ft. You just differentiate Laplace transform of ft and change the sign. The differential of Laplace of cos 60 is s by s square plus 36. You differentiate this. So that's what it is. How do I differentiate this? Product, not product, what's this called? Quotient. Quotient rule is what you have to use. So I've done the details here, but I'm not going to spend time on this. I'm sure you know how to differentiate this. So L of t cos 60 is basically whenever I want to multiply a function by t and find the Laplace, all I need to do is to find the Laplace of this function and then differentiate it. That's the procedure. And change the sign, of course. So I've done all that part here. I hope I've done the computations correctly. Find Laplace transform of t e power minus t sine phi t. Let us see this. This I have see previously what I had done, t was not there. That means e power minus 2t sine phi t I know how to find. Or Laplace of t into sine phi t I know how to find. Now both are there. How to do? Do the same thing twice. Do the same thing twice. If I know Laplace of sine phi t, then I can find Laplace of t sine phi t. How do I do? Differentiate. Then what do I do? How do I find Laplace of e power minus 2t into t into sine phi t? I replace s by s plus 2. That's all. So that's the trick. Examiners love this kind of thing where you're convolutedly asking the same thing twice. So e power at, so this function t e power minus 2t sine phi t is e power at into t into ft. Of course, we can first multiply this, means first you can try to find, first in any case you have to find Laplace transform of sine phi t and then replace it by s plus 2, s by s plus 2 and then differentiate. But differentiation, if you do it earlier, it is better because once you replace s by s plus 2, the expression will look more complicated. To differentiate that is the same thing, but you need to put in more effort. So use your brain and first, since e power minus at into ft is easiest, you have to replace s by s minus a. So you keep that in the end. So first you do Laplace of t sine phi t. That I know how to do it. You have to find Laplace of sine phi t and differentiate that and change the sign. And then I will use e power minus 2t into t sine phi t as of the form L of e power at into ft, where this capital F is not same as this capital F. This capital F is Laplace of e power at ft. Sorry, e power ft. This ft itself is t sine phi t here. Here ft is sine phi t. Understand the difference. So this f and this f is not are not same, but due to lack of better notation, I will use this. What I have written is correct, but try to understand this f and this f are not same. They are different because here ft is different from this ft. This ft is t sine phi t, whereas this ft is just sine phi t. Understand the difference. And then details are written here. So you see, I want to find Laplace of t e power minus 2t sine phi t. So first I'll find Laplace of sine phi t, which I know is 5 by s square plus 5 square. And then Laplace of t sine phi t is minus of d by ds of this, which is this. And then I will find the Laplace of e power minus 2t into t sine phi t. I replace in this, I replace s by s plus 2. That's what I've done. Don't try to simplify this, leave it like that. How much time do I think I'm done with the 1 hour. So I'll stop here. I'll continue with this further again. I'll recall these things before I start the next. Thank you for your attention and please feel free to ask me if you have any doubts.